Hey guys, it's lesson 3.1 algebraic expressions. I can't believe we're at chapter 3 already, but look, here we are and we are going to get right to it. Okay, what is an expression? It's a mathematical phrase that can contain numbers, variables, and operators. So here are some examples of algebraic expressions. We have a variable right here, and right here, but we also have some numbers in there too. But it's important to definitely know the difference between an expression and an equation. So here are both like examples on how they are different. So an expression, it can't be solved. You have no equal sign. So really you just simplify it as much as you can. You can't add a 5 to an x, so this is as simplified as it gets, okay? And then equations can be solved and they have an equal sign. So we can solve for x here and it has an equal sign, so that's how you tell the difference. But today we're just mainly going to focus on expressions, so you don't have to actually ever solve for x in this lesson. Okay, essential questions. How can you simplify an algebraic expression? Okay, so identify the terms and like terms in each expression. So the terms are just all of the numbers in here. So I'm going to grab a pen. So terms. We have 9x, comma, -2, comma, 7, comma, and -x as our terms, okay? And then the like terms are, so we have 9x and 2, thought it was 2x, but it's actually just x. Okay, and -x, and then we have -2 and 7, because these both have x's and these are both constants. Okay, over here our terms are z squared, 5z, -3z squared, and then z. So it's important to not drop, means to not drop this, because if we would add up, this is going to be a -3z, okay? Add up here, that's a -2. Add up here, that's a a -x. So these go with the terms, okay? And then our like terms are the z squared and the -3z squared, and then the 5z and the z. So z squareds are different than z's, okay? On to the next. Okay, it says simplify this expression. So when they say to simplify it, they want us to add together all of the like terms. So we have 3, I'm going to add up this and add up that just so I can see it better, but we have 3/4 y plus -1/2 y, and then plus 12 plus -6. So I rewrote it like this so I can see my like terms right next to each other. This is going to give me a 6, and then this is going to give me something, but I can't just see off the top of my head. So I'm going to multiply this by 2/2, so I get the same denominator as this. So that gives me -2/4 plus 3/4 y. So that's going to give me 1/4 y. So we get 1/4 y plus 6 as our expression, okay? Okay, so now this one wants us to identify the terms like we did before and the like terms. So the terms that equals, we have 2r squared, comma, 7r, let me add up these, comma, negative r squared, and last but not least, the negative 9. Okay, so those are our terms. Our like terms are the 2r squared and the negative r squared, and then we have a 7r and we have a negative 9. So we only really have 2 like terms, and then these ones are just solo. Okay. And then they want us to simplify the expression. So we look at this. These are like terms. We're going to have to add those together, and this is just going to have to come down regularly. But 2.5 plus 4.3, we get a 6.8x. So this is our answer. Not too bad, I don't think so. I think it's good. This is like my favorite stuff, algebraic expressions. That's like so beautifully nice, I feel. Okay, so now looking at, please excuse my dear Aunt Sally, we're going to have to start with parentheses. And I know you guys all know this because we spent so many times, and you guys, oh my gosh, made such beautiful posters. I'm so proud of every single poster that you guys made in that class. You totally outdid yourselves and were so much better than 8th grade, just so you know. Okay, so we're going to have to do, whoop, whoop. Okay, so we get negative 1/2 times 6n. That's going to give us negative 3n. Okay, I'll write it over here. So we did 1/2 times 6n. So that's over 1. That equals negative 6n over 2, which simplifies down to this negative 3n. Okay, and then we did negative 1/2 times 4. Put that over 1. We get negative 4 over 2, and that's going to give us plus negative 2, and then we have plus 2n, which is just right here. So we did the distributive property and found these two terms, and then we just kept this one how it was. Okay, and then so these two are like terms, and this is just going to be brought down. So this is negative 3n plus 2n. That gives us negative 1n, and then plus negative 2, and this is what we were looking for. Yay! I think it's all right. I don't know about you guys, I think this is all right. Okay. So I'm going to do one of these, and I'm going to hope that you guys go back and, do the other two, but it's just if you really don't know how to do it and you need some more practice. Okay, so we have to do the distributive property first, because these are in parentheses. And so that gives me negative 2g, and then plus negative 2 times 4 is negative 8. And then I bring down what's ever left over, and that's plus 7g. Oh, yay, those are the same. So 7 minus 2 is going to give me 5g, and then plus my negative 8. Woohoo, that's so awesome. I seriously don't think these are all that bad. Okay, so now we have a story problem, but actually it's really nice. It's a fun story problem, okay? So let's just, put your seatbelt on and let's go for this ride, okay? Each person in a group buys a ticket, a medium drink, and a large popcorn. So they're going to buy a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies. Interpret the expression. Okay, so we literally have no idea how many people are in this group. So that's obviously going to have to be represented by X because we just don't know. And then, so each person is going to buy a ticket plus a medium drink and then plus a large popcorn. So the prices are right here, so we can fill in those. Okay, so we have X amount of people that we don't know buys a ticket, which is 7 750 plus the medium drink, which is 2.75, and then plus the large popcorn, which is $4. I'm just going to write it like that because I ran out of space. Okay, so we could add all these in here and then multiply by the x, and that's how much money that they're going to spend. So 750 plus, okay, so this is actually going to be, so this is going to give us 6.75, and then we're going to have to add it to this one, but I'm going to make it like this so I can see it better. 100 plus 675, 100, that equals 1,425 over 100, which equals $14.25. Okay, and then so I'm going to erase all this junk right here. I'll need a bigger eraser. Okay. So technically then, this adding the ticket and the medium drink and the large popcorn, we're going to get $14 in here. But we don't know how much the group spend because we don't know how much people were actually there. So we can just leave it like this expression. And then, so if we're interpreting this expression, we're saying that, okay, if there were 5 people, they're going to spend 14.25 times 5 amount of money. If there were 10 people, you plug in 10 for x. So x represents the amount of people that are in the group, but we don't know how many people are in the group because they didn't tell us. So this is how this expression works, because we can just easily, once we figure out how many people are in the group, we can easily just say, okay, each person's going to spend 14.25, so depending on how many people are there, we could just plug that in and figure it out. However, you could have even, I'm not going to do all of it, but you could, if you didn't see what I saw, you could have been like, okay, well, we don't know how many tickets there were, so we could do this. We don't know how many large drinks there were, so we can do, medium drinks, 275 times x, and then plus our $4 times x, okay? And then we could add like terms, and it would give us that 14.25x that we were looking for. So even if you didn't do it like I did it here, you could have easily done it like this, and you would have gotten the same answer. Okay, that's the end, and that's a really ugly smiley face, but he's saying good job, and that's awesome, and algebraic expressions are awesome, and keep up the good work, and I'll see you tomorrow. Goodbye.